Well, welcome, everyone. Thank you very much for coming out in the slightly chilly weather. My name is Alyssa Goodman, and I'm the co-director for science here at the Radcliffe Institute. And so I welcome you also on behalf of Radcliffe. Some of you may have been here earlier this year for our annual last year now, for our annual science symposium on the Undiscovered. And the theme of the Undiscovered, for those of you who were not here, has to do with not completely by accident or serendipitous scientific discoveries, but discoveries that are made when you have a plan for what kind of science you want to do, but then you find something you didn't exactly expect, but you are very prepared. And so Dan Kammen, who you're going to hear from today, will talk about that kind of work a bit in the context of energy research and potentially, hopefully, saving the Earth. And so it falls to me to tell you about Dan, which I will do in just a minute, but also to mention that there are 2 more talks coming up within a week in this series. So we have one on Friday and one on Monday, and they both have a life science bent, and the information is on the Radcliffe website. And so if you haven't registered for those, 2 more talks in the Undiscovered series, one Friday and one Monday. I should also mention that the first few rows here are filled with people. The reason I'm wearing a name tag today is that as another activity at Radcliffe, we're having a 2-day seminar, small seminar on trying to marry data science approaches and climate research across all fields: law, business, economics, earth science, health. And we'll let you know how that comes out, hopefully at another event in the future. But one of our participants for that is my friend, Dan Kammen. And so Dan Kammen and I first met when we were both graduate students here in physics in the late 1980s. Yeah, Dan looks younger than me, though. But anyway, so Dan, like I said, we both got degrees in physics, and then Dan's path diverged fairly quickly, where he got more and more interested in energy and energy policy. So he has also an undergraduate degree in physics from Cornell, and then he went on and did postdocs at Caltech and came back to Harvard, and then he went to Princeton as an assistant professor. But for the last 20 years, he's been at UC Berkeley. And the list of titles that Dan has doesn't even fit on the page that I have in front of me, so I just selected some to give you some taste of what he does. He's currently the class of 1935 Distinguished Professor of Energy, the chair of the Energy and Resources Group there. He's also appointed in the Goldman School of Public Policy and the Department of Nuclear Engineering. He's the founding director of the Renewable and Appropriate Energy Laboratory, the co-director of the Berkeley Institute of the Environment, the director of the Transportation Sustainability Research Center. I left some off. He's very lazy, as you can see. And he's founded or is on the board of more than 10 companies. And some of you may remember his name from the newspapers and the news because he has advised the Obama administration and the World Bank, and extremely briefly, the Trump administration on energy and sustainability issues. He also was the coordinating lead author for one of the IPCC reports, the Intergovernmental Panel on Climate Change. And you may remember that Al Gore and the rest of the panel won the Nobel Prize for their work in 2007. So because Dan shared that prize with so many other authors in addition to Al Gore, who got half the prize, he told me I'm allowed to call him a micro-Gore. So also, you may have seen Dan. When you see him, he might look familiar. He's been on many, many television programs, and in particular, he hosted a 6-part series for the Discovery Channel called Ecopolis. And so I'm going to stop taking Dan's time away and just say that I'm really excited to hear him tell us about an energy plan that the Earth can live with. And the plan is that we'll hear from Dan, and then we'll take questions at the end, and there'll be a microphone in the aisle. And when you'd like to ask a question, please do come to the microphone. And thank you very much, and thank you for coming, Dan.
You used it. Well, thank you all for being here on what for now a Californian feels like a very, very cold evening. So I really appreciate everyone getting here. I have to say, though, that I feel even more sort of attuned with the Undiscovered path because you can tell a fairly good story about what I've done afterwards, but at the time, I came to Harvard to do cosmology. I actually transferred here. I won't get into that right now. but I got here and then I got seduced into studying neuroscience and the evolution of the brain. And it's actually the complex systems part that I feel like has been the most useful in the work I've done. And I hope that that kind of appears as we go. But it's a story you can tell the ties afterwards, but I sure cannot tell a coherent story at the time. It was an interesting wander through a lot of very nice benevolent neglect along the way. And so right now we're at a point, though, when we need to do much more than benevolently neglect the planet. And so I'm hoping these will tie together a little bit. And what I'll try to do is to give a bit of an introduction to my laboratory, because the way that it functions is critical to the mixture between basic science, applied science, and engagement with a variety of non-governmental groups and governments and others along the way. And I'll use that to really look at how quickly the energy system of the world not only is changing, not always for the better, but the ways in which we critically need it to change. And so this is the part that will bore the experts in the room, and I apologize just a little bit, but really to use that to look at what are we learning about how to guide and steer innovation for a decarbonized world, and that's really what I get at. What I find exciting is that we, like all academics, say all hard problems we haven't solved, we are waiting for the younger generation to solve. And I do remember when I felt like I was one of those younger generation folks, which I do not anymore. And right now, we are at a point where the 15-year-old Swedish school children and young 29-year-old members of the US House of Representatives and a variety of others are absolutely doing exactly what we say in a very casual way, those sorts of changes. And so I'll end with this call for a just transition, which is probably a more accurate title than energy plan that the world can live with, because it's not clear that the world is going to be too happy with the energy plans that we are creating. So I'll jump into our lab for a second just to give a feel for it. It's quite a diverse group of individuals, lots of different backgrounds and interests, and it's quite international. It's really quite diverse, and so there's a lot of approaches. Most of the people that find their way to this energy and resources group came out of a STEM background, but increasingly we have people from philosophy and rhetoric and a variety of other areas as part of the mix. And it's been really heartwarming to see the number of people who feel like they have a huge input on how we think about energy innovation. And it's not just the kind of the material science and physics and chemistry world that I sort of assumed when I founded the lab would be the main pieces of it. So anything that I'll talk about today, the slides from today's talk, so the papers and things that I'll mention, the video clips, they're all available on the RAIL website, Renewable and Appropriate Energy Laboratory. And you do need to type into Google more than just RAIL, because if you just put in RAIL, you will get the Railians who claim to have cloned a human 10 years ago in Florida. Haven't heard a lot from them since. So my name or Berkeley or something like that. And then the Twitter is not vacation pictures. We try to post about one tweet a day. Today was a bit heavy for reasons I'll get to in a little bit about the work from the laboratory. So RAIL has existed since I moved to Princeton, from Princeton to Berkeley 20 years ago. It's actually when John Holdren had departed here to Harvard, and so there was a spot available for a ex or former or something sort of physicist. So we've been working since, and the big project we worked on for the first couple of years that Alyssa mentioned was that I've been part of the IPCC team. It actually started when I was here at Harvard under a NIGEC, Northeast Regional Center for Climate Change Fellowship in the 80s. And then in the 90s, we worked really hard on a lot of the climate assessment, detection of climate change work. The big benefit was that we got this wonderful, got to share in the Nobel Peace Prize, which was wonderful. But I don't know how critical it is here at Harvard, but at Berkeley, getting the check is great. But as you know, if you're part of a big team, you don't get the Nobel Prize check. You get this nice plaque, but you do get something much more valuable at Berkeley, and that is a parking space with a big, large NL on it for Nobel laureate, and I was really waiting for my parking space to impress my friends and sort of annoy my enemies. Nothing happened the first year, 2007, 8, 9, nothing. Finally, a couple years ago, we said, oh, we're gonna act on this finally. At Berkeley, there were 4 members of the IPCC team, Inez Fung, Kirk Smith, Bill Collins were all part of the core team on campus and the Lawrence Berkeley Lab. And so we were told, yeah, you're about to get the award, you're going to get the parking space, and it's totally Berkeley, and they absolutely delivered what they said. We got a parking space. Nobel laureate bike parking, and you got to read the fine print. Parking not reserved for IPCC contributors. So the very few times I go there, there's like 16 student bikes in a huge heap. It looks like some sort of twisted metal thing from the Matrix, but it is very Berkeley specific, and so it's a Berkeley did us proud. Our lab is sort of generally thinking as interdisciplinary as possible as we can about climate issues, but we still come from a technical perspective. And so every now and then, our forays into, I'm not going to call it economics, I don't want to even claim that, but sort of financial engineering I would describe. And so one of the things that we came up with was a way to finance energy efficiency and renewables, something called PACE, Property Assessed Clean Energy. It's basically pirating the simplest idea out there that municipalities around the United States often lend money to property owners to underground transmission lines or repair sidewalks. And so we borrowed this idea, set up a company. 16 states passed laws to enable PACE financing, and it's worked relatively well, but it has a critical flaw, and that is to get municipal money to invest in renewables and efficiency, both things that make sense, you have to own property. And that means it is inherently a regressive policy. It borrows money from all of us to pay off those who are better off because they own something. And I'll come back at the end to the halting steps towards this just transition, or a socially equitable version of a change in this really critical problem. Since then, our lab has expanded the work we've done with governments around the world to help them think through how to do planning for an energy transition. And this has really been the most interesting feature for me. My kind of complex systems background, interest in basic material science, be it for new batteries or heat pumps or whatever the technology, fuel cells is we're looking at the time, but it's really how to synthesize that into complex enough models, but also models that can be translated for work by governments, by nonprofit groups, by activist groups, by the private sector. And I'll give a few flavors of that as we go. And we've worked with a whole range of governments. I just put some flags of a few of them up there in places that have made interesting strides. And I should highlight that may not be obvious. We hear a lot about China, and I'll come back to China. And we have Mike Danielson and others in the room who have real expertise. But in terms of places like Kenya, you don't hear about. Kenya is in some ways the Silicon Valley of East Africa. Morocco is the only country that legitimately went to the climate conference this past December in Poland and were on target to meet their 2050 goals. The only country. And why it's in Africa, it's an interesting story. And Malaysia has a really interesting story around decentralized energy. So there are some really curious leaders emerging in this field. And that'll get me into kind of the core part of the talk, and that is we have to make this great energy transition, but we are moving too slowly. And the things that have caused some of the most interesting and most rapid progress, some of them are obvious, but I will do kind of a sort of a take on them. But even though I assume that no one here who came to this talk in the first place, who's in Cambridge, at Harvard, MIT, and various places, needs any kind of a primer on climate change. But we all have somewhere in our family tree that crazy uncle or aunt who doesn't believe climate change and has 9,000 arguments that they'll trot out over Thanksgiving dinner until you pass out from tryptophan poisoning, and it's their argument why climate change isn't happening. And one of the interesting aspects of that is that the climate community on the science and engineering side is very dedicated to our models and our increasingly complex models. And while I'm as guilty as anyone, one of the challenges is to try to be able to encapsulate climate change in a model-free way. And you can look at a given heat wave or this or that, but you can always get someone say, well, 80 years ago or 100 years ago, there was a similarly bad event. And so one thing that I use and urge anyone who has that sort of troublesome aunt or uncle in your family is a wonderful NASA, you can download this from the NASA website, and what it's going to show in, I think, 28 seconds or so, is a series of synthetic images taken each point during one image per year when the sea ice over the North Pole hit its minimum. And that means it could be late August, early September, depending on that coldest moment. And so this is a critical part of the story, because these are simply images taken, no modeling involved. And what you're going to see is not only this, but a graph in millions of square kilometers showing the amount of ice. And so those of you who have watched Chasing Ice and now Chasing Coral, I heartily recommend both of those. But you see there's some fluctuations, but starting out in the late 80s, of a little bit less than 7 million square kilometers of ice at its minimum in the late summer. There are some warmer colder years. I think I debated Bjorn Lomborg in '96 at a kind of a peak. But you see, we have, in a very steady secular way, lost about 50% of the ice cover. And for those of you who have seen Chasing Ice know, very graphically, and it should make sense physically, you don't just lose area, you compact volume. So you're losing a dramatic amount of ice. And again, in a modeling-free way, that's a pretty good slide set to just play back to that annoying relative who insists that they're going to tell you all the reasons why climate change is due to other things. In my worldview, though, one of the hallmark events that I think will go down in history, even though the recent history we've seen has been a little challenging, is the fact that we've had so far 24 of these COPs, these climate conference of the party meetings. But before the Paris one, this is called the famous event where we got this wonderful agreement, in 2014, President Obama and Premier Xi met, and they essentially said, this 189-country negotiation, this is a pain in the blank, and we're just going to do a two-party conference. After all, we are the G2 of messing up the planet. We are 40% of global energy use, 40% of global pollution. If we come to an agreement, it will really change things. And in fact, that's exactly what happened. The agreement was bizarrely asymmetric from a political science perspective. President Obama pledged to cut emissions by a third by 2025. China promised to peak emissions. De-emissions, DT is equal to 0. But they didn't say if that was going to be at 2% or 2,000% over the current level. And of course, the US has now backed off, to put it mildly, the clean power plan that Obama proposed. China, on the other hand, that gave itself till 2030 to peak emissions, is going to peak emissions sometime probably in the next 6 to 7 years. So China's going to meet its target much earlier and much lower than anyone forecast. And so a really interesting mix. Of course, these promises that were made at the Paris Climate Conference are things that we've committed to and haven't done yet, and that's part of the problem. But what happened is that I then evolved the work I was doing from just at Berkeley to a larger federal role, first under Secretary Clinton, and then under Secretary Kerry. And so we worked in a variety of capacities, in my case, as science envoy working with North African, Sub-Saharan African, East African, and Middle East countries on their energy plans. It was a wonderful time. At the end of it, you get kind of the sort of wonderful letter from the president thanking you for trying to be a liaison for good planning and bringing science to bear on the problem. But then, of course, the US, we had a little election, and that election didn't go well, certainly from my own perspective on things. And so it was time for me to depart the administration, and I, at home, said, I'm not going to keep serving under this new president. And my wife said, well, does that mean you'll be around the house more? Which I wasn't sure was a good or bad thing from her perspective. But my kids said, well, Dad, if you're going to do it, there's only one way to do it. You have to tweet it out. And you have to tweet it out in ways that I learned from my children. So my younger child said, well, if you're going to tweet, you have to tweet at 6 a.m. California time, 9 a.m. East Coast time, middle of the day in Europe. And you have to tweet your message out in a way that will have a few sort of interesting features. So I tweeted out my message. I'm the son of a historian. And so I had quotes from various presidents of both parties. I thought it was being pretty clever. No one read the letter at all because I did have a little acrostic embedded in my message. And this is when I started to really listen to my kids. Not only should I do it early in the morning, but then my younger daughter challenged me, said, you have to have your most famous friend retweet it within a few minutes. So that got more tricky. I thought and thought, who do I dare approach? Who do I ask? So I did ask my most famous friend if she could retweet it, and she did. And by the end of the first day, according to my daughter, I was out trending for 9 nanoseconds. Taylor Swift, by the end of the first day, it was just kind of an interesting process. And so that put me back into my day job at Berkeley. And thankfully, a number of other parts of the world have moved on very steadily. It's really hard to meet our climate targets without the US engaged, but because if we look at business as usual path for emissions, if there's the business as usual line, you can just see if the US and China collectively don't get their houses in order, we are not going to make it. There's lots of arguments about how you can have the treaty work and blah, 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 but in the end, these two major players are going to have to really make progress. And what was agreed to in Paris wasn't just fueled by a lot of good wine, although it helped. It was a remarkable transition, and the idea that we were on a pathway in terms of billions of tons emitted and in terms of the temperature change we were on a pace for. The orange or red or whatever that color up there is, that's what the commitments made by the US, China, EU, and everyone else were going to shave off. Now, those are pledges made in 2015, and as I said before, only one country, Morocco, is actually on pace to get anywhere. So talk is certainly cheap, and paper apparently is even cheaper. But that was what we all committed to, shaving a degree right off the top. And remember, we have already warmed the planet by 1 degree. So it's not that we have 2 degrees of room. That was the negotiated, we must cut our emissions by 80% or more to keep emission rise less than 2 degrees, given that we've already warmed by 1 degree. And so we were there. And really what countries committed to were the so-called national commitments, the NDCs, and they add up to this. Some countries pledged to be much more energy efficient, some to do renewable energy, others to protect forests, wetlands, a whole variety of very eclectic things were proposed. And the job of the Conference of the Parties is to really hold us to that fire, hold us to those targets. And right now, we are not doing so well. But the Paris climate meeting also did something else. And that is, the red is what we committed to, but it was such an enthusiastic meeting that a very unlikely set of some European and the United States and many developing nations said, this 2 degree number, that's not enough. We need to keep emissions lower still. And one real failing of the science community, and I'm as guilty as many colleagues, is that we didn't go to this Paris meeting with models for how to go much lower in hand. A few groups had them, and people trotted out proposals that they'd written to agencies that didn't get funded, or whatever else, and to say, well, we were thinking about going lower than that 80% cut in emissions. Very few of the academic community was ready to step up, while world leaders got together and said, 2 degrees, that's the goal, but we're really after 1.5 degrees, the so-called high ambition coalition, because that sounds better than low ambition coalition. And in fact, what happened was we need to do everything in the gray. Those are all additions. We need new science, technology in a whole variety of areas, new policy mechanisms, new behavioral tools. But 6 months after the Paris Climate Accord, my boss, Secretary Kerry, at the State Department, led the US effort to pass the so-called Kigali Accords that were signed remarkably fast and then ratified right away. And those called for about another 0.5 degree to be cut, largely through refrigerants and some industrial processes. But it shows you how quickly this whole system can change, at least on paper. And you have to make good on it. Now, you don't have to be too technical to note that if 2 degrees requires getting emissions very near zero, getting to 1.5 degrees is going to require scenarios that go carbon negative. And this has opened up all kinds of dialogue around, do we invest in geoengineering? Do we invest in smarter agriculture? Do we invest in healthier soils, rivers, ecosystems, so that the natural world can suck carbon down? So there's a fascinating and very complex discussion about how to actually do this, but it's a really critical story. And so if I stop there, I would have not done any of the details, but that's what we all promised. Of course, the US backed out, which is why I resigned my federal job. But what gave us hope that you could get there? And for me, living in California, it's really this remarkable story that if you look at electricity use per person in the United States, it's been rising in California, not so different than the rest of the country. And of course, where California took that dip and the US took that little hiatus, that was the OPEC crisis. And the engineering savvy folks will say, well, wait, an OPEC crisis is about oil, but we don't run our power plants on oil. We run on coal, natural gas, nuclear power, some renewables. And so what happened? In fact, the economic slowdown resulted in less demand. But the real thing that happened, in my view, in California, right during that little plateau, is that California set up a new state agency to start planning around energy transitions, modeled very much after some work that had taken place in Europe. The Energy Commission took off, and instead of seeing electricity use just simply rising per person, and there were well-thought-out arguments that if you wanted to grow your economy, energy use must rise. In fact, a sort of unfortunate, very famous, but an unfortunate economist, anthropologist at University of Michigan, I won't name him, Leslie White, he actually said that culture evolves as the amount of energy consumed rises. And in fact, you all on the East Coast may have your doubts about California in terms of culture, but by doubling and tripling down on residential, commercial, and individual home energy efficiency, California stopped electricity growth per person, and it has remained that way for decades. There are some interesting details that are worth hashing out, but that's a remarkable process. Of course, we have so per capita, we've leveled out, but of course we have a lot more capitas, and so we need more power, but that is a wholesale change in terms of economic thinking, and it leads me to one of the first kind of undiscovered observations for me, and that is this kind of data enables a whole bunch of much more interesting planning, but it also reveals one of the problems, and that is that while we know that we need to meet this climate target of reducing emissions, one of the far too general observations for me is that humans are very, very poor at doing any decision-making that doesn't seem to involve money. And when I was at Princeton, I had the office next to a now Nobel laureate in economics. He's actually not an economist, but we had huge problems because on the corridor there was Dan Kammen and Danny Kahneman side by side, and we never got our own mail or messages or anything. But he, among others, in the behavioral economics world, really went on to think, how do we develop other metrics? How do we think through how we're going to assess features? And the fact that nature does not care about money means this whole dialogue is incredibly difficult. That doesn't mean that a carbon price alone will solve our problems, but it's incredibly difficult to get there because what nature really cares about is carbon emissions and suck down, so the net flux of carbon and time. And unfortunately, we are doing ourselves no favors until we can find a way to translate nature's currencies of carbon and time, and perhaps land use and water, into financial terms, or translate our financial terms into money, into these natural units. We're not going to get there. So as an example, many places have done strategies. In California, we set a target for 20% of our energy to come from renewables by 2010. We missed the goal through a party, got there 3 years late. Our next goal for 2020 was 1/3 of energy coming from renewables, and we are already over that. California will probably end 2020 somewhere between 37% and 39% powered by renewables. That is amazing in itself, and while every jurisdiction has a different definition, California does not count large hydro or nuclear as a renewable. You can agree or disagree, that's just the bookkeeping California chose to. Our 2030 goal was 50% powered by renewables by 2030, but Senator Kevin De Leon and others worked to pass a bill, Senate Bill 100% of our energy from clean sources by 2045, and 60% by 2030. And California is certainly on path to meet that incredibly lofty sounding goal for for 2030. Now, this leads me to not only talk about these climate goals that I've done most of the talk so far about, but also about the real secret sauce in this, and that is that a number of places related to discussions that have now led to the Sunrise Movement, to the Green New Deal, to a new bill that's now has Republican and Democratic support, sponsors at least in the House and Senate, to start having a revenue-neutral carbon price. All of these have led to a much bigger discussion, not just about climate change, but about equity. And I really want to sort of hammer on that as we go, because I actually am amazed we've gotten as far as we have without making a more just version of this transition possible. So some of the things that have happened in the California process along the way are interesting. Leading up to this, 10 years ago, we started with an effort to say all new homes built in California after 2020 must generate as much energy as they consume, so some mixture of energy efficiency, and rooftop solar is kind of the poster child for it, but it could be heat pumps, it could be ownership share in a wind farm, not on your property. A whole variety of things have gone into this, which when we initially proposed this 9 years ago, people thought were impossible. It is passed, it's law in California, and now we get construction companies saying, we only have 11 months to get to this target. And we say, well, you could have come along with the process and the discussion ever since. And we're getting all kinds of clever proposals for what to do in a home that simply can't have solar on the roof because of trees, or a place like Pacifica with a lot of fog. And we're finding interesting proposals. Our equivalent of Star Market in California, Safeway, has now proposed they would host solar. Your home doesn't have it on the roof, but you have an ownership share in that solar they host on their building, and it's part of your property. So there's lots of things going on there to sort of think through how to do it differently. At the same time that we passed this one, that is now law, and it was considered a reach, there's an even bigger reach. We passed at the same time that by 2030, office buildings of indeterminate height have to also be carbon neutral. Now, we know how to do this one, but we do not know how to do this one. But in the go along with an innovative strategy, California has actually adopted this as well. So it's really interesting mix. Another version of the story about how do we convert our dialogue to think not just about money is something that several places in the world started to highlight. The California version was to say, let's not just have a quota system for clean energy, let's also do it for our fuels. 10 years ago, when we started to work on this, almost everyone who thought going to clean fuels for vehicles were thinking biofuels. I was certainly part of that. I wrote a paper that was widely used to set a standard for it. We went on 60 Minutes and variety of things. And that rule basically said phase out gasoline, move to biofuels, except that you have to do the cradle to grave, the life cycle analysis of are those biofuels actually sustainable? Well, it turns out, of course, if your biofuel comes from urban waste from Boston, probably it's a good thing to use it for fuel. If it comes from cutting down Amazonian forest to then grow soy, not so good. And so what California did was adopt something called the low carbon fuel standard. And it said that if gasoline is our benchmark in terms of grams of carbon per megajoule, we have to take into account the source. And so if you move to Midwestern corn, just look at the blue for a second, it's somewhat better. Sugarcane is quite a bit better. Ethanol that's made from dry materials are better. But none of them are home runs. They're a few percent better than gasoline in life cycle. They don't solve the story. And in fact, there's a vicious debate going on around the green, which is called the indirect land use. And it's a very controversial economic part of the story. But there are lots of fuels that are unambiguously better. And so there is a future for biofuels. But as we all know, there's been a push into electricity, which has really changed the game. And I'll come back to that in a little bit. So when I mentioned this timetable, we need to get to roughly 80 or 90 or even 100% decarbonized, depending how sort of optimistic you are by 2050. That's not the whole story. The other story is encapsulated in this paper for which Christina Figueres, who was the chair of the climate process, and now she's head of the European Climate Foundation, highlighted, and that is that every year we go by with increasing emissions, that's the tan line, of course makes our peak higher, so you have to reduce emissions more. But that's not my worry. I believe we can beat this down for the technologies we'll be talking about in the next few minutes. The worry, though, is that if we keep that 2050 goal as our serious goal, which it must be, then the slope of these lines really becomes the worry. The blue line, or whatever that turquoise color is a 3% decarbonization sustained for decades. The rust-colored one is 4, and the red is 5%. And the problem is that we're talking about not just 1 or 2 years, we're talking about decade after decade of sustained innovation. And the two best documented examples are that California, for about 7 years, maintained 3%. And while China's energy demand grew, they cleaned their mix so dramatically that they also averaged about 3%. But no place has averaged the 4 or 5%. And so the longer we wait to really start this in earnest, the more the slope of this line becomes the real challenge in the process. And that's really the issue. And so the other far too general or sort of undiscovered observation for me is that we used to think of the energy system as a supertanker. So it takes, the analogy is not only the oil, but also takes miles and miles to turn. But more and more, we need to think about it somehow as a supertanker trying to be a startup. And how do we mix the culture of, this is the biggest investment we have in terms of infrastructure on the planet, and we need to change it dramatically quickly. So in the last 10 minutes, I want to highlight some examples, and I'll do them very quickly in terms of some of the waves of innovation that have really give us some tools for decarbonization. The first one is my favorite, most complicated graph in the world. Maybe not the most complicated graph in the world. We'll leave that for astrophysics. But the most complicated graph in my field, and that is a graph showing the progress in solar energy on the material science side. So this incredibly busy picture just shows for the traditional big silicon cells to smaller blue, the crystalline ones, to thin film, new emerging technologies, to the reds, new perovskites and quantum dots and organic cells. You're seeing the best efficiency of a whole variety of technologies with the laboratory group that held that record at the time. And yes, the slope of that line over time gives you one metric of innovation. And thankfully, these newer entrants coming onto the scene have higher slopes. They're raising more rapidly. Very exciting. And it's this mixture of technology push, new innovation funded by governments, by companies, that gives us a really diverse resource, meaning there's many different solar technologies. Back when I started this, when I started working on this a long time back, when I did my first summer of work at the US National Renewable Energy Laboratory, there was really only the purple and the blue that were seen as competitors. Now all of these are looking interesting candidates. That plus increasing manufacturing, largely in Asia, and markets growing around the world, first in Japan, then Germany, then California, and now many places, have led to kind of a famous picture, and that is this thing called the learning curve. And this is loved by people who think about applied energy. I think it's loathed by some of my economics friends. But the idea here is, and notice this is a log plot, no apologies made. So price on the y-axis and doubling and order of magnitude changes in production on the x-axis. In log space, you get a so-called power law. This is Moore's law, where we see a very steady decline. For most technologies that are mass-produced, you get about a 20% drop in price every time you double the amount in manufacturing. If you trust it, you can then forward price. You can give subsidies, you can give incentives so that we manufacture and deploy more, banking on a lower cost. And solar has done this remarkably well. So when I started working on this area, solar was 40 to 60 cents per kilowatt hour, depending where you are. Now, we have projects going in initially in the Middle East and now elsewhere. Solar at 3 cents. People said that was impossible. Then in first Saudi Arabia, and then New Mexico, and now Chile and the Atacama. We have solar projects going in for under 2 cents a kilowatt hour, commercial cost. And this is just transformative. And that diversity of technology I mentioned means that there's all kinds of amazing innovations to come if we keep deploying to give us demand pull and if we keep investing. In fact, right now, there are transparent solar. There is solar that works off of the indoor light, so you can have solar on your roof, generate electricity, recapture and solar inside a building. We have thin and flexible solar. We have technologies that are really interesting. We just hired a professor at Berkeley, and her specialty is wearable solar. So your jacket is solar. You can charge up devices. I mean, it's a fascinating world. Almost none of it was forecast some decades ago. So these learning curves are wonderful. They're heuristic. There's a debate about them. I'm writing a book right now called The Learning Curve to look at the mix of technology push and aspirations. And if we look at them, they're generally sloped. You can see the photovoltaic one, PV. There's wind. There's NOx controls. And then there's this nuclear one. And that's a problem. So if these are learning curves, I don't know if you call that an unlearning curve, a forgetting curve. I'm going to get in trouble. But that's the data for the US. Now, you might posit that the next generation of molten salt reactors, of traveling wave reactors, of small modular reactors will change this entirely, and it might, and I am a professor of nuclear engineering, but the actual data shows that in the last few decades of US installation, nuclear prices have been rising. And that is a huge worry. In fact, I won't even go into the story of when nuclear was first brought to the market in the United States. So there was a campaign to make nuclear attractive to homemakers, women. That program had the awesome name, Adam and Eve. I'm just going to move right along past Adam and Eve. The new player in the world of energy is, in fact, storage. And storage, while it's much newer in terms of the diversity, has the same interesting range of learning curves, from lead-acid batteries in cars to nickel metal hydride to lithium-ion batteries. And we spend a lot of time with our colleagues at Imperial College and Cambridge and elsewhere examining these learning curves. And actually today, storage is improving as fast as solar ever did. And that brings me to the last part of the talk, and that is that we now work with governments to build models of their power systems to think about what investments in new transmission lines, in energy storage, in energy efficiency will you need to reach a variety of targets. And so right now, the green are places where we have active models in use by governments, and the blue are places where we've promised and committed to building a model of the power system. And for the electrical engineers, this is a so-called capacity expansion model. It is a beast in terms of computation. I won't get into any of that here, but we've had some really interesting lessons come out of this process. And the biggest one is that as these new technologies have emerged, we have discovered a whole variety of interesting new ways to do things. So for those of you who've been to Kenya, this is the Ngong Hills wind farm. This wind farm was the first wind farm in Kenya. There's lots of good wind sites. It was placed here because the Ngong Hills, you can see them from Nairobi, and specifically, you can see them from the offices of the state-run utility. And so you can see them in operation. There's real learning and experience, and Kenya has now progressed to be this incredible climate leader. Of course, with some investment support by countries I won't mention, the United States and China, there is now an effort to build a coal plant in China. And so we will see about that. The other interesting feature of this story of mass production and technology innovation and evolution is that there are lots of areas where we didn't plan for solar to be the opportunity that it's now become. So sub-Saharan Africa, a $25 billion a year industry, very expensive over its lifetime, but very inexpensive to bring home a little lantern, but then you're committed to buying fuel. Well, the range of small solar products that initially looked like just glorified flashlights, that then became flashlights that have built-in radios and flashlights that now get better and better at a whole variety of tasks, mean that we've taken those incredible cost decline curves, and the fastest form of new energy access, not powering a whole home, but device by device, is now what we call pay-as-you-go solar. So this is basically you take the device home with often no down payment. On trusted mobile money, you make daily or weekly payments online. You bring the device home, and the data science and IT aspects have just become fascinating. So in a big project we did with the World Bank, we studied this process, and as an example, this was an initial sample of 1,000 homes that had these devices in them. And we looked at what people were going to have to do. They were going to have to pay about 50 cents a day on average over a year to own the devices I just showed you. So we started to gather the payment histories of people and look at the state of charge of their batteries. And we observed, oh, here's one. They're paying it off just fine. But here's one where they don't seem to be using it all. So what we collected here were those financial histories. Of the 1,000 or so dots on the graph, the blue ones are all people who were paying off, and at the end of the year, they paid enough to own their device. The red ones are people who started to pay or whatever else, but ultimately didn't pay enough, and the company that provided it turned it off. And some of these stories are just amazing. What we started to do a few months in was to send text messages to anyone whose device wasn't working. So, can you tell us what's wrong? And they would text back, oh yeah, it's not working. And we ask where it is. Well, it's actually under the mattress. Well, you know, the solar panel doesn't work well under the mattress. Or it's outside, but it's covered with cow poo. And so we send text messages back, doubling the usage rate in 6 months. And so they ramped up. We still had about 8% failures, but remarkably ramped up. The demand rose. Companies began to build other products. Now you can take home televisions, DC-powered refrigerators, a whole variety of devices to make the mixture of those solar panels and LED lights and little batteries work. And then there's big batteries. To meet California's climate goal, we used this model called Switch I mentioned, to examine what would be needed. And we found in California is we're going to need a lot of storage to come online. Both long-term seasonal storage, like reservoirs, but also storage that works with you over the course of a day. And through that, we wrote a requirement that now Germany has copied as well, and now Denmark is writing one, where this is a new type of battery. There's actually an amazing professor here at Harvard, Michael Aziz, who works on one of these flow batteries. Unlike the several thousand cycles in your cell phone, this flow battery, it's a sulfuric acid liquid battery. This one is powered by solar, and this has millions of cycles. And so you can change the story remarkably, and this was one of these early installations to provide storage under the California grid. The other story of the grid is really interesting, and that is as we install more and more solar, we go from a demand curve from the middle of the night that's pretty flat, only students are awake, we think, and then the more solar we install, California's on a path to have 1 million solar rooftops by the end of next year, which means roughly 1 out of 15 households. But when you install more and more solar, the net demand, or the demand left over, gets hollowed out. So we now have a situation where there's very little demand that we forecast to be on the grid during the afternoon, but everyone comes home and you turn devices on, so you get this incredibly sharp ramp. And this is called the duck curve, where we will have this huge, not only need for power, but over this short period of time. Well, another way to look at that duck curve is that every power engineer over about 40 knows that peak demand comes in the late afternoon when devices are on at home and office and on the hottest summer days. California now forecasts our peak demand will be at night in the winter because of low solar. And so when you look at this curve a little differently, this is an excess of green during the afternoon that if you have storage, such as the commercial one I just showed you, or your electric vehicle, you could sell power back and make that available later in the day. And so we're seeing this kind of remarkable thinking about how to dual use your electric vehicle. And the economics, once the vehicle prices are the same, are remarkable. At $3.50 a gallon, it's about 14 cents per mile to drive your car. But at rooftop solar at those commercial rates, it is 1 cent. So more than an order of magnitude cheaper to drive your electric vehicle. Now, the vehicles themselves need to be comp replaced, but we're getting pretty close to that. And the last thing I'm going to highlight at the end is that we not only have Tesla thinking they're going to not only sell you all cars, but electric trucks. And we have things like charging lanes where you inductively charge as you drive down the road. And instead of parking places where you must pull in, charging pads that can be moved from car to car. So instead of running out to your car in the parking lot at Google or Amazon or wherever else, the charging pads just simply move from vehicle to charge you up. And if we don't do it, guess who will? This is China's map not only of the 2.3 million EVs they have and the 279,000 charging stations, but on their national map, they also track the number of electric vehicles in the United States, EU, and Japan. So you can bet they're thinking hard about how to make this happen. Now, the last thing I want to say, because I'm right at the end, is that one of the challenges that I mentioned at the beginning is that if we don't make this transition one that's much more inclusive, we make our job impossibly hard. And climate scientists, clean energy engineers like myself, I think have done a terrible job of making this inclusive. And of course, if you provide subsidies for electric vehicles or for solar, whether you can justify it with those learning curves or not, you are subsidizing the rich with the poor to put these technologies in place, right? And when you have socialism for the rich and capitalism for poor, that is not a recipe for an inclusive process. And so we've done a fair amount of work to look at this story. And so we used a large 60 million rooftop data set from Google, did a lot of machine learning that I won't get into the details, to look at the roofs, to track the solar panels, to look where they are, and to use census data to examine which homes they're on. And so the sad part of the story, I'll just go to the conclusions right at the end, is that even when you control for income, solar is 30 to 40% more prevalent in neighborhoods that are white, Caucasian dominated, and 30 to 70% less prevalent in Latino and African American residents neighborhoods, even when income is controlled for. And so if we don't think about ways to do this better, subsidies for community groups, ways that landlords and renters can share the benefits of going solar, we make this transition incredibly difficult. We make this story about a green transition near impossible. So I'm going to leave you just at the end with the last part of the story that came out of not only the IPCC and then the climate conference in Poland, but what has now become discussed as this Green New Deal. So one of the things I was asked to do by Governor Schwarzenegger was to build a carbon footprint tool, a calculator, that will allow you to look at your data. And so we did that. We built versions that are available for homes, businesses, and schools. It's called coolclimate.berkeley.edu. The data sets are wonderful. There's kilowatt hours used for each zip code on average, natural gas consumption, goods and services, transportation and food. And at the end of the day, what you discover is that the ability to think differently is kind of remarkable. So the last page when you go through one of these online calculators, this one that we built, is that it tells you your footprint, that's the top part, but then this take action page is the thing that's really caught a lot of attention. And when we release a new version, we get like 100,000 hits a day. So this take action list tells you all the things in our database that you, the homeowner or school or business, didn't do, and what each one will cost you or save you in money in carbon terms. And so we have got this sort of hilarious process where people will use the calculator and they quickly go and look at the most equivalent homes. So this is called Keeping Up with the Joneses, where you look at, I have 5 people in my home, it's a 3,000 square foot home, and people look down the database to see what do other homes that are equivalent to you, both in terms of size, number of people, geographic location, and then go look at what people did here and look at the stories about which of these things people really took advantage of. And so this process we now do for all of California, we do it for Germany and Japan, and zip code by zip code. This is actually down to the parcel level. We see all kinds of sort of interesting dynamics in terms of people learning from each other. And I want to end with that one because one of the critical things that's emerged from the climate process is that as fast or as slow as we are in this process is certainly a function of new technology and of innovative policies, hopefully more progressive than regressive, but policies that find a way to empower individuals to make decisions, whether the individual is a homeowner, a school, a business, or a municipality. And if we don't find a way to really enable all of that, we make this job of this just transition and this energy process near impossible. So I know I raced at the end, but I wanted to highlight the degree to which this sort of information system has really changed the story. I would love to hear questions, and I'd also love to hear examples of things that have worked and not worked in your own experience. Was it hard or easy to do this or that, to weatherize, to buy into this and that? So I hope that you'll share some of those, and I want to thank you all for coming tonight. Thanks very much.
Hi, and thank you for your insightful talk. And I would like to ask, since we mostly focused on California and other countries, what do you think the challenge will be for us to expand to other states in the United States?
So, great question. We're actually in a better spot than one might think. Over half of US states have these clean energy targets, these so-called RPSs. President Trump did cancel the Clean Power Plan that I thought was a wonderful piece of policy. But we have seen coal use drop dramatically. So coal that was over 60% of US electricity is now down in the 30% range. The entire value of the coal industry, the CapEx of all US coal, is under $50 billion, meaning that Jeff Bezos and Bill Gates could buy 2 of them if they wanted. So the idea that we are wedded to coal anymore is certainly not part of the story. That opens up an interesting next part of the story, and that is that in some parts of the country, California as an example, gas is the dirtiest fuel possible, and it's one we know we need to phase out. But in other places, the biggest change they can make is to move from coal to gas. And so you get this interesting mix state by state. The Clean Power Plan, something that I would recommend whoever decides they want to get the US back on track, put back into effect right away, said each state needed to decarbonize by 1/3 relative to its own baseline. It didn't require states that have started late to battle with New York and California that started earlier on, but it's given us a mix. And so actually I think right now we were in a good spot. If we do get the Clean Power Plan restarted in some form, we'd really be there. And the sad part of the story is that the Clean Power Plan actually called for $8 billion to be provided as retraining and retirement money for people in the coal industry. And the sad fact is that I do not believe the coal industry will ever get as good an offer as it got under the Clean Power Plan, which means that the retirements that will ultimately happen now are going to be uglier and more painful for working class Americans. And so I think the US could rapidly get back on this path, but I fear that unless we really do get this kind of Green New Deal mentality, we are going to stick it to the least able to deal, and that's the people who have been in coal mines for so long. So great question. I'll go faster afterwards, sorry.
I'm going to take you up on your offer. This is the 3rd iteration of my solar backpack, and I suspect I'm the only person here who is carrying solar.
Nope, I am.
Good. What it is a $10 solar charger and light, right? And a piece of plastic. I'm going to use this as my headlight on my bike as I bike home. $10. Retail, online, anywhere around the world. What, 1 billion plus people?
Without access.
Without access. Retail price, $10 billion, which is less than a day's worth of what we spend on the global military, right?
Yep.
So that's one thing.
I'm going to ask you to jump to the question, though. Just,
well,
I'm in agreement, but yeah.
I won't give you a question, but I'll give you another resource. Geotherapy, right? Which is the Marin Carbon Project in one case. This is a way to bring down the carbon out of the atmosphere. And Boston, Cambridge happens to be a hotbed of information about this, but it's not happening at Harvard and MIT.
Okay.
I had an entirely different comment to make.
Okay.
I was wondering whether long-term you thought it made any sense to change the curriculum of pre-college education, at what stage is not quite clear to me, to teach these things for the long term and teach the teachers, to produce.
Right. So,
Get
I mean,
back on
the obvious answer is yes, and thankfully Harvard has one of the most innovative professors of science education, and that's Eric Mazur. And I have seen just remarkable things come out of the cooperation that they and many other groups, but Eric's team in particular, has done to think about how to integrate these programs in. One of the most interesting things of the climate conference, and much of the, sort of the attention to this, incredibly eloquent and powerful Swedish 15-year-old has been the real demand for schools striking over not getting better climate action, not getting better education. And when the kids in schools are asking for it, I would say this is kind of perfect territory. And so I would absolutely think that's the case. Every science museum, every school, there's huge opportunities to really make this a core part of the curriculum. So I'm hoping, and there are some really good efforts, but they're individual pockets. They have not become the kind of the ubiquitous, better environmental and science literacy that many people have called for. And so Pedro Noguera and Eric Mazur, a number of others have been remarkable on this, but I think this is absolutely critical to this process. So.
Thank you very much. Great talk. Clearly, you're doing wonderful things. I do have a concern, and I'm interested in your insight into whether locally green policies in California contribute to it being so expensive to live there that no one can move there. So they all move to Texas, where they're forced to run their air conditioner for 9 months out of the year. Do locally green policies, is there a risk that there's a net effect that they're globally brown?
So this is a really interesting question. This is part of this whole doing a just transition. And the story is not the same in every single neighborhood, but the California data, the data from Portugal, the data from Denmark is very strongly indicating that high residential prices are not due to higher cost electricity. In fact, California has some of the most expensive electricity in the country, but some of the lowest electricity bills in the country. And that's largely because per kilowatt hour it's more expensive, but by being very aggressive on efficiency, as is true in Florida, Wisconsin, New York, it is not just a California thing, that overall story has been a plus. And that leads me to one other thing that I cut out just because I obviously ran long, and that is that the data is unequivocal that clean energy technologies generate more jobs than the fossil sector. Now, that's not because it is superior in any way. That's because if you're building a new technology base and one where you're not paying for fuel, it's not surprising you get more jobs per dollar or RMB invested. It's that you're building a new sector. But the fact that you're not putting a huge amount of the money into the fuel means that you're investing in people and companies and IP. And so we have incredibly diverse data sets that show hugely larger job creation. And my worry is that places like California that have really doubled down on it, where over 40% of all US venture capital in clean tech goes through California, are going to do well in this deal. But when, and I won't name states, Mississippi, and others that are not exactly on the leading edge finally decide to go there, that green jobs dividend will have been eaten up by those who went early. And so instead of being a penalty to go early, there's a big benefit, but this has to be more inclusive. California is less than 1% of global emissions. And so greening California, but not spreading the policies that we have, the policies from Bangladesh, from Kenya, from Denmark, from places that have really jumped way ahead, from Morocco, it means we're not going to get there. And so I think you're highlighting a key worry, but the places that have acted actually have done quite well in the deal on that basis. California is too expensive for a lot of other reasons. That is, everyone chooses to live within, myself included, within 20 miles of the coast, and the key the key residential hubs are also the places for these booms of new companies. Housing prices are crazy. We have graduate students at Berkeley on food stamps as a result of unaffordable housing. But it's not due to clean energy. But the worry is proper.
I just have a question. You were talking about the Clean Power Plan. I was wondering what you think about the Regional Greenhouse Gas Initiative as compared to that.
Yeah. So you guys are under a program as well. The challenge here has been that while RGGI is now improving a fair amount, the carbon price is very low. And the worry is that if we had started this process of launching carbon prices early on, a low price now that ramped up very slow would be fine. And the contrast would be this new bipartisan bill introduced in the House and Senate is one that calls for the carbon price to start higher than California's current price, which is about $12 a ton, start more like 20, and go up by $10 every year. And that reflects how much we need to move more quickly because we've really delayed. And so, RGGI is good. The ETS, which is also at its ups and downs, figuratively and literally, is also a good thing. But I think that the lesson we've learned so far is that a carbon price is critical because we need to have this dialogue between financial metrics and others. But the places that have moved ahead globally have not done so relying on a carbon price. It is one arrow in the quiver. It's silver buckshot, as Al Gore likes to say. It's not a silver bullet, unless the price gets so high for which the politics may really become challenging. So it's a neat point.
Hi, thanks for coming and speaking with us. A friend of mine, an economics grad, is moved to Brazil to work on deforestation in the Amazon, and I'm hoping to join her and learn a little more down there. So on a micro level, what are some strategies that can help on the deforestation forefront? And on a larger level, the election of Bolsonaro is definitely a very bad news for the Amazon. Yeah. What can we do on that larger level other than shake our heads?
Well, so there's no silver bullet answer to that question, right? But it is interesting that Brazil got a huge amount of early, very positive press for investing in sugarcane ethanol. And the early sugarcane was largely on land that had pulled back from former rubber production and others. But it's become so profitable that sugar expansion and related crops digging into the Amazon has become a huge issue. And so when you look at that graph I went over in terms of the carbon content of liquid fuels, it's just striking. If you really do use bio-waste, then there is no environmental penalty you should add to that liter of biofuel. But if you're cutting down rainforest, it turns out that you would need to run your ethanol production for over 100 years to pay back the carbon that was standing in those trees in the rainforest. And believe me, this is not a happy conversation, right? So if everyone in the front row is a current food farmer that decides to go into biofuels, and you decide you're only going to collect municipal waste, and so you have no carbon penalty. But Alyssa here says, I'm going to convert my current corn production into biofuels. I'm going to do it sustainably. I'm going to bless it. I'm going to all these things. It's going to be great. But someone elsewhere says, well, she's no longer producing corn. I'm going to get into that business. And increasingly that's in Indonesia, Brazil, the Congo, Malaysia. Then you're cutting into forests that had a much better value as forests than as ethanol producers. This conversation does not go well in Brazil. And I have my mentor is the father of the Brazilian ethanol industry, an amazing figure. He was the host of the Rio Climate Conference. And this is an area where we're on sensitive ground. And so finding a way to lead with the facts and the numbers is my physics tribe way to do things. But this is a really hard conversation. And so working in the area, what you guys are proposing to do is what I recommend. But finding a way to compare the life cycle, the cradle to grave analysis is a critical part of it. But that's a seed change. And so we don't have a lot of years, but that's a critical part of the process. That's hard. So. Yeah.
My question was around the corporate world. When the CDP put out a report that says that the 71% of carbon emissions are being generated by 100 companies, and we're talking about, countries and governments and things. What are you or others in your field doing to help educate and help these companies transition away from this carbon emissions?
So this is actually, this is an area where my economics colleagues can give much better answers than I do. And this is the place where I would argue the carbon pricing can have the most value. The fact that carbon enters our economy through so few spigots, you mentioned the kind of, on the order of 100 companies, that's a remarkably small number. So arguments to regulate carbon at the user end may be the standard policymaking tool, but doing it upstream makes much more sense in terms of efficiency, even if the increased price gets passed down. The challenge, of course, is that if you increase the price for production for those companies and don't find a way to give back to low-income people around the planet, then your policy might be right for the planet, but it's not part of this just or equitable transition. And so one of the features that I'm hoping the dialogue around the bill, that I really like the bill in many ways that's in front of the House and Senate, is to not just rebate all of the revenues back to all Californians equally. I said Californians, sorry about that, to all Americans equally, but to actually say, no, we're going to give back an extra share to the lowest income Californians. So what I would do is a hybrid of the Ocasio-Cortez, and that would be if you are within 200% of the poverty line, I would give you back your share, but also a share taken from the top 0.01%, and use that money both to give back to low-income Americans and a part that's not in the bill. There is no provision to harvest money from the bill for research. And I would argue if you want to do this, you give back a lot, but you also need to hold the fund. And we've seen this work. President George Bush started ARPA-E, the Advanced Research Projects Agency for Energy, modeled after DARPA. It's been phenomenally successful, but it's got a budget of $300 million a year. And if you want to make a dent here, we need to at least get to the level of what the US spends on pet food research, which is over $1 billion, and that's just a start, right? So great question.